Recording in progress.
Assalamualaikum warahmatullahi wabarakatuh. Swastiastu, Nama Budaya, Salam Kebajikan. Good morning, ladies and gentlemen. Welcome to International Conference on Tropical Agriculture, Feed and Food. Is in honor of us, I, Dimas Rahmat Nurmutakin,
and me, Yumi Almarida,
we are glad to be your master of ceremony today. Ladies and gentlemen, first of all, let us say thank to God who has given us many mercies and blessings so we can attend and gather in this event.
hadirin yang berbahagia, mengucapkan bersyukur kepada Tuhan Esa atas berkat rahmat dan hidayahnya kita bisa bersama dalam rangkaian acara.
Recover stronger, building a sustainable and resilient agricultural system. Diano, Rector of Universitas Mulorman.
Yang terhormat Rektor Universitas Mulorman atau yang diwakili oleh Profesor Dr. Isya MSI.
Diano, Vice Dean of Agriculture Faculty of Universitas Mulorman.
Yang kami hormati Wakil Dekan 1 Fakultas Pertanian, Bapak Profesor Dr. Benatar Saragi MSI.
Diano, Chairman of Committee International Conference on Tropical Agriculture, Feed and Food.
Yang kami hormati Ketua Panitia Bapak Dr. Insinyur Abdul Samad Ramayana MP.
And Diano, all keynote speakers and all audiences.
Kami hormati semua keynote speaker dan semua tamu undangan.
Ladies and gentlemen, now we're going to next agenda is deliver of national anthem Indonesia Raya.
Acara selanjutnya yaitu menyanyikan lagu Indonesia Raya. Hadirin berdiri. Hadirin dipersilakan duduk kembali.
May our agenda goes well. Let us start this by praying first, read by Dr. Matrawi.
Mari bersama kita berdoa dan akan dipimpin oleh Bapak Dr. Makrawi. Kepada Bapak Dr. Makrawi, disilakan.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Ladies and gentlemen, let us bow our head for a moment and pray to God Allah subhanahu wa ta'ala so that our international conference can be precious to our hearts. I will lead this prayer based on the teaching of Islam, and those who are not Muslim, you are pleased to pray according to each of your beliefs. أعوذ بالله من الشيطان الرجيم. بسم الله الرحمن الرحيم. الحمد لله رب العالمين. حمدا شاكرين، حمدا ناعمين، حمدا يوافي نعمه ويكافي مزيده. يا ربنا لك الحمد كما ينبغي لجلال وجهك وعظيم سلطانك. اللهم صل على سيدنا محمد وعلى آل سيدنا محمد. اللهم إنا نسألك سلامة في الدين وعافية في الجسد وزيادة في العلم وبركة في الرزق وتوبة قبل الموت ورحمة عند الموت ومغفرة بعد الموت. اللهم اغفر لنا ولوالدينا وللمسلمين والمسلمات والمؤمنين والمؤمنات الأحياء منهم والأموات إنك السميع قريب مجيب الدعوات يا قاضي الحاجات. Allah, most gracious and most merciful, today Tuesday, September 19, 2023, in this beautiful place, we gather here to bring about an international conference on tropical agri-food, feed, and fuel. The theme is Recover Together, Recover Stronger, building a sustainable and resilient agricultural food system. Make this international conference a useful science assembly as a medium for sharing useful ideas, knowledge, and experience of scholars, researchers, and students of various disciplines. May the conference we organize today benefit our life, broaden our knowledge, shine our ideas, and lead us to be successful, productive person, which in turn will boost the dignity of our nation. Allah, the source of peace, guide to bless our heart and our mind with the light of your guidance. Impart your supreme wisdom upon our activities. Help us to speak our mind clearly. Help us to listen to each other, respect each other, love each other, so that we are included to the blessed person. Oh Allah, show us the straight way. Protect us from unlimited temptation. Show us the right path and give us knowledge and strength to perform good things. Equally, show us and make clear the bad thing and give us knowledge and strength to avoid them. Oh Allah, you are the one, the eternal, absolute, who can fulfill our dua. ربنا آتنا في الدنيا حسنة وفي الآخرة حسنة وقنا عذاب النار. سبحان ربك رب العزة عما يصفون والسلام على المرسلين والحمد لله رب العالمين. يا رب العالمين. السلام عليكم ورحمة الله وبركاته.
Thank you, Dr. Macaulay. The next agenda is report by Chairman of Committee International Conference on Tropical Agri-Food and Food.
Hadirin yang kami hormati, selanjutnya adalah laporan Ketua Panitia yang akan disampaikan oleh Bapak Dr. Abdul Samad Ramayana. Kepada Bapak Dr. Abdul Samad Ramayana, disilakan.
Assalamualaikum warahmatullahi wabarakatuh. Good morning. Whom I respect, Rector of Mula Warman University, Dean of Faculty of Agriculture, Mula Warman University, Deputy Dean, Faculty of Agriculture, Mula Warman University, main speaker, speaker and moderator, guests, as well as we are proud of the seminar participant and attendants. Ladies and gentlemen, thank God to Allah Subhanahu wa Ta'ala who has given His grace so that today we can attend the ICTAFF International Seminar, Faculty of Agriculture, Mula Warman University in good health. The ICTAFF activity is a biennial research dissemination agenda that has been carried out by the Faculty of Agriculture, Mula Warman University since 2018. This is that ICTAFF activity carries the name Recover Together, Recover Stranger, Building a Sustainable and Resilient Agriculture Food System. University as center for the development of science and innovation must be able to provide the best solution to increase production and maintain the quality of food product. The use of science, innovation, and technology is critical to meeting the global challenge of producing food more efficiently, improving nutrition, and helping families who depend on agriculture for a living become more resilient. Ladies and gentlemen, in connection with this international seminar, we presented 5 resource persons as main speaker, namely Sensei Professor Evangelis from Okayama University, Professor Normas Wana Ismail, Deputy Dean from University Putra Malaysia, by Zoom, Professor Orawan Panpipat, Walaila University Thailand, by Zoom, Professor Sazedul Haq, PhD, Patua Kali Science and Technology University Bangladesh, Professor Sahat Pasaribu from BRIN Indonesia, and Dr. Odit Ferry Kurnia Dinata from Faculty of Agriculture, Mula Warman University, as well as 60 people as accompanying resources, person from various domestic and foreign institutions and universities. On this occasion, allow us to thank to the Rector Mula Warman University, Dean of the Faculty of Agriculture, Mula Warman University, the sponsor who have participated in this seminar activity, as well as the highest appreciation to the entire committee who have worked wholeheartedly for the success of this seminar activity. We realize that the implementation of this international seminar still has many shortcomings. For that, we apologize profusely. Finally, I hope that all seminar participants who attended can get the maximum benefit from this seminar activity. Billahi taufiq wal hidayah. Assalamualaikum warahmatullahi wabarakatuh. Balikpapan, 19 September 2023, Chief Executive Dr. Samad Ramayana. Thank you.
Thank you to Dr. Samad Ramayana. The next agenda is welcoming speech. The first welcoming speech will be delivered by Vice Dean of Agriculture Faculty of Universitas Malayana.
Sambutan kedua akan disampaikan oleh Wakil Dekan 1 Bidang Akademik Fakultas Pertanian Universitas Mulia Warman. Kepada Bapak Profesor Benata Saragi MSI, disilakan.
Thank you very much to all the participants today, especially to our invited speaker from Japan, Professor Ivan, also juga Professor Normas from Malaysia, and all of the participants today, especially our dean, also our rectors, and thank you very much, and honorable, especially to all of the team, especially steering committees, the chief of the committee, Professor Dr. Samad Ramayana. Assalamualaikum warahmatullahi wabarakatuh. Selamat pagi, salam sejahtera kita semua. Salam Om Swastiastu, Namo Buddhaya, Rahayu Rahayu, salam kebajikan. Ladies and gentlemen, I would like to say thank you very much today, especially in this nice morning, as a good of session and things, and you know, currently we are facing a global challenge, especially for the food situation in Indonesia, and also in the abroad. All of the global situation, I think, now still a problem, especially the high of price of food in Indonesia, especially rice. In this week, for it achieve also a highest of the rice, especially price today. This is a problem now. And we also challenge the food sector is not only require use of the safe waters. Also, I think the diet, I think, because we are in need of a supply of food today, because our people increase, especially in East Kalimantan, because we have now of a new capital city in Indonesia in Kalimantan. This is one of challenge or a problem, especially to us in agriculture sectors, because we need the higher food to give to them. Ladies and gentlemen, and also currently in Kalimantan, Indonesia, we have a fresh opportunities at the same times, I think, for fighting on food with the population. We have mentioned about the more than 2 million people in 2045 years. The next, we reach 2 million people, I think, especially in Kalimantan, and we need to building the capacity to support the food supply in Kalimantan, I think, especially the new capital city of Indonesia, the name of Nusantara. Ladies and gentlemen, the building of the food super hub, this is the ideal things, especially station of food in a capital city Nusantara, how to manage the situation, especially the problem food, especially distribution and logistic of food in Indonesia. As we know, we are a country, one of the country the higher of the logistic food in the world. We compare about the Malaysia also, and Singapore and Brunei and another the Asia, especially also maybe higher than Japan, because we are the most the island. We need the logistic and transportation to distribution of food in Indonesia, especially we compare and others, Australia also. We are more than high logistic food, price and logistic legislation in the world. How about supporting the food IKN? We give the name of the IKN. By integrating the other region, especially food station, supporting our region, especially the east of Kalimantan, something like the Penajam Pasir Utara region, also Kutai Kartanegara. We think this is the two region to support our IKN, especially also in Kalimantan also. This is our problem now. How the international conference on food and feed and fuel to support this situation
we need of the conclusion today and recommendation, especially to give to our country, to give to a new capital city and also in East Kalimantan. I think this is our I mentioned today, and thank you very much for your coming and enjoy this seminar of International Conference on Agriculture, Food and Feed and Fuel, recover together, recover stronger, building a sustainability and resilient agriculture, our system of Indonesia and the West. Thank you very much.
The next agenda is second welcoming speech will be delivered by Rector of Universitas Malawarman.
Sambutan selanjutnya oleh Rektor Universitas Malawarman dan sekaligus membuka acara secara resmi atau yang diwakili oleh Bapak Profesor Sudiansah MSI. Kepada Bapak Profesor Sudiansah, kami silakan.
Assalamualaikum warahmatullahi wabarakatuh. Selamat pagi, salam sejahtera buat kita semua. Semoga Bapak dan Ibu yang kebetulan hadir di ruangan ini selalu mendapatkan limpahan rahmat dan keberkahan dari Allah Subhanahu wa Ta'ala, Tuhan Yang Maha Esa. Kalau tiga pembicara sebelumnya semuanya menggunakan bahasa Inggris, maka izinkanlah saya pada hari ini, pagi ini menggunakan bahasa Indonesia. Daripada saya gunakan bahasa Inggris, nanti Bapak Ibu semua tidak ngerti. Pertama-tama ingin saya sampaikan permohonan maaf dari Pak Rektor, karena sebenarnya beliau akan membuka acara ini pada pagi ini, kemungkinan bisa jadi karena pesawat beliau delay dari Jakarta sehingga terlambat datang. Dan beliau berpesan pada saya untuk menyampaikan kata sambutan pada hari ini dan sekaligus nanti meresmikan kegiatan seminar pada hari ini. Yang kami hormati dan kami muliakan Bapak Ibu narasumber, yang pertama Bapak Ivan dari Kayama University, kemudian Prof. Normas dan suami dari UTM, kemudian Prof. Warawan Tampipat dari Walailat University, kemudian Prof. Sasidul Hakwe from Bangladesh, kemudian Prof. Sahab M. Pasaribu dari mata saya agak green, ya, kemudian Dr. Odit Ferry Kurniadinata dari Universitas Malawarman, khususnya Fakultas Pertanian, dan semua guru besar yang telah berkesempatan hadir pada acara seminar internasional pada pagi ini. Ya, mudah-mudahan Bapak Ibu semua mengikuti acara seminar kita hari ini sebagai sumbangsih kita dalam membangun pertanian ke depan. Kalau kita bicara tentang pertanian, Bapak Ibu semua, tidak bisa kita pungkiri bahwa pertanian itu adalah kehidupan. Tidak ada satu makhluk hidup pun di permukaan bumi ini yang tidak butuh hasil pertanian. Jadi dapat dikatakan tanpa pertanian maka tidak ada kehidupan. Oleh sebab itu kita terus berpacu dengan waktu. Bagaimana kita menyiapkan pangan bagi kehidupan ini, bagaimana kita menyiapkan pangan untuk generasi kita, bagaimana kita menyiapkan pangan sampai di ujung kehidupan kita.
Kalau kita bicara tentang pangan, misalnya saya ambil contoh saja, misalnya beras, misalnya. Jadi kalau kita bicara pertanian tidak hanya bicara tentang beras, tapi bolehlah saya ambilkan satu contoh komoditi bahwa kalau kita bicara tentang beras, kita bicara tentang nasi, maka dapat kita katakan hampir 60% penduduk dunia ini makanan pokoknya adalah nasi atau beras. Nah, dari 60% penduduk dunia itu, 90% penduduk yang makan nasi itu ada di benua Asia. 90% dari benua Asia itu 90% ada di Asia Tenggara. Dan dari 90% di Asia Tenggara itu 90% ada di Indonesia. Jadi bisa kita bayangkan kalau terjadi goyangan produksi terhadap beras itu, maka kita bisa bayangkan bencana kelaparan yang akan terjadi. Jadi oleh sebab itu, maka kehadiran kita pada hari ini, ya, kita berseminar, kita bertukar pikiran, kita bertukar pendapat, bagaimana kita memacu pertanian ini, ya, sehingga ke depan pertanian, pangan, kebutuhan pangan kita bisa tetap tersedia, dan kehidupan kita bisa terjamin, tidak hanya buat kita, tapi buat generasi kita yang akan datang. Belum kita bicara tentang komoditi yang lain. Komoditi yang lain juga kita terus berpacu dengan waktu. Berapa kebutuhan daging yang harus kita siapkan, berapa kebutuhan telur yang harus kita siapkan, berapa kebutuhan sayur-sayuran yang kita harus siapkan, dan berapa kebutuhan buah-buahan yang harus kita siapkan, dan itu harus kita pikirkan, dan itu jadi tanggung jawab moral kita yang bekerja di sektor pertanian. Seringkali saya bila diminta mengisi acara sebagai narasumber, seringkali juga selalu saya sampaikan bahwa hanya orang-orang yang tidak waras yang mau bekerja di sektor pertanian itu. Kenapa demikian? Kalau berhasil, tidak ada rewardnya sama sekali. Tidak ada rewardnya, tidak ada pengharganya. Tetapi begitu gagal, sumpah serapahnya yang luar biasa. Tapi itulah, berbahagialah Bapak Ibu semua, kita semua bekerja di sektor pertanian menjadi orang-orang yang tidak waras, tapi percayalah Bapak Ibu semua, kita semua adalah orang-orang yang paling dekat dengan pintu surga. Alhamdulillah. Paling tidak kalau kita tidak masuk surga Bapak Ibu, kita sudah ada di dekat pintu surga. Jadi jauh dari panasnya api neraka. Begitu. Tapi mudah-mudahan dengan aktivitas kita di sektor pertanian yang jadi orang yang tidak waras itu menjadikan kita orang yang pertama masuk ke dalam surga. Amin ya rabbal alamin. Bapak Ibu yang dirahmati dan dimuliakan Allah Subhanahu wa taala, memang di dalam kegiatan seminar ini kita tidak cukup bicara food security-nya saja, tapi kalau kita bicara tentang pertanian maka kita harus bicara dari hulu sampai hilirnya. Karena hilir tidak akan ada kalau tidak ada hulunya. Tapi kalau kita bicara berkesinambungan maka pertanian itu adalah ibarat pohon yang tak ada ujungnya, ibarat tali yang tak ada ujungnya. Jadi tidak pernah putus sampai di hari terakhir kita menghirup udara di dunia ini. Saya kira demikian yang bisa saya sampaikan Bapak Ibu semua. Mudah-mudahan apa yang kita seminarkan hari ini, kita sampaikan hari ini menjadi amal ibadah buat kita semua, baik kebaikan orang banyak, dan mudah-mudahan keberlanjutan dari seminar ini bisa kita lakukan di tahun-tahun berikutnya. Selamat berseminar. Mudah-mudahan Bapak Ibu selalu dirahmati dan diberkahi oleh Allah Subhanahu wa taala. Dengan mengucapkan bismillahirrahmanirrahim.
Mohon izin Bapak.
Saya kira demikian. Wassalamualaikum warahmatullahi wabarakatuh.
Baik, mohon izin Bapak untuk dapat bertahan karena simbolis secara resmi kita akan mengawali gong bersama, dan kami juga undang dengan hormat kepada Bapak Wakil Dekan 1 untuk dapat bersamai, Bapak Ketua Panitia, dan kami juga mengundang kepada seluruh keynote speaker. We would like to invite you on the stage, Bapak Prof. Evangelis, Ibu Prof. Normas.
Can I smile? Please. Boleh. Oke.
Dengan mengucapkan Bismillahirrahmanirrahim, maka acara seminar internasional topik
Kayaknya ketinggalan of agri-food fit and full saya nyatakan secara resmi dibuka. Baik, Bu. Ibu pukul. Monggo, Bu. Ih. Oke. Kasih.
Baik, kami mohon kepada Bapak Ibu untuk dapat bertahan karena kita akan mengambil sesi foto bersama di atas panggung. Jadi kami mohon kepada Bapak untuk dapat maju ke depan. We would like to take a picture together.
influences. Please stand by on. We will take picture with the audiences and all participants.
Kami mohon kepada seluruh audiens untuk dapat berdiri dan maju ke depan bersama sesi foto bersama dengan seluruh keynote speaker hari ini.
Participant and audiences, we will take a picture with all the keynote speakers.
Kami undang seluruh partisipan untuk dapat mengambil sesi foto bersama ke depan
Take a picture with them,
dengan seluruh keynote speaker.
please. To the all participants, please, some of participants. On the stage, okay. Please, Bapak, Ibu, silakan boleh ke atas. Kepada Bapak dan Ibu, boleh di atas. Iya.
Baik,
Bisa di sela-sela antara teman yang lain agar terlihat.
mungkin kepada seluruh panitia juga bisa ikut ambil foto bersama. Silakan maju ke depan di stage. Baik, saya izin memandu sesi foto bersama hari ini dengan hitungan ketiga. Two, three. 3, 2, 1. Oke, bebas Bapak Ibu, silakan. Freestyle. 1,
Okay, thank you to all participants. Please have a seat. We continue our agenda.
Baik, terima kasih kepada seluruh Bapak Ibu yang sudah bersamai sesi foto bersama. Jadi dengan pemaluan game, secara resmi acara International Conference on Tropical Agri-Food Feed and Food telah dibuka.
Ladies and gentlemen, we will continue our agenda. Now, we will show you a traditional dance by UKM Balikpapan Public High School 5 by Exotica.
Tari Exotica Borneo merupakan tarian Dayak yang menggambarkan tentang keindahan alam Borneo. Terinspirasi dari tarian-tarian suku Dayak Kenya, Dayak Bingka, yaitu tari enggang, tari go, tari perang, dan tari gentar. Perpaduan keempat tarian tersebut secara struktural masing-masing memiliki keunikan tersendiri. Keunikan tersebut terangkum dalam rangkaian penampilan tari Exotica Borneo. Selamat menyaksikan. Baik, tepuk tangan yang meriah untuk penampilan tarian dari ICTAFF Borneo.
Please give applause for the dancer of the Seliwa High School 5 Balikpapan. And now, ladies and gentlemen, we are going to a coffee break session before going to the plenary session. To all audiences and all the guests, please to enjoy our snack and beverage.
Bapak Ibu yang kami hormati, selanjutnya adalah sesi kopi break. Sebelum kita memasuki sesi plenary session, kami persilakan kepada Bapak Ibu untuk dapat menikmati hidangan yang telah disediakan oleh panitia. Terima kasih.
Tiga, dua, satu, untung.
Kita masuk ke sesi plenary session dan kami mohon kepada Bapak Ibu untuk kembali menempati tempat yang telah disediakan.
Jewish August University of Göttingen, Germany. Research interests, plant breeding, molecular breeding, and technology.
University 1987 and the Master Degree in Gajah Mada University 1993 and the doctoral in Pajajaran University 2002. This interest in this science and education chairman of the Indonesia.
Nur Hasana and Dr. Enci Ahmad Syafiri. Time is yours. Assalamualaikum, Prof. Nur Hasana. Assalamualaikum semuanya, Bapak Ibu sekalian. How are you today? How?
Okay, thank you, Bu Nur Hasana. In the first session, we will invite 3 speakers, yeah.
Yeah.
But 2 of them are coming
Join us
online.
online.
Yeah.
Okay, but before we come to our speakers, we want to greet you all. Good morning, all of the distinguished guests, honorable speakers, and all of the participants of the third ICTAFF International Conference on Agri-Food, Feed, and Fuel. Welcome in Balikpapan, East Kalimantan, our new capital city of Indonesia, IKN Nusantara.
Yeah.
Okay. Anci, yeah. On behalf of the organizing committee, I am Nur Hasana and my partner is Bapak Enci Ahmad Saifuddin. Today we have a privilege to be a moderator for this first plenary session with the first 3 speakers. Our first speaker is
Acai Prof. Worawan Panpipat from Walailak University.
yes,
And then Sensei Prof. Ivan Galis from Okayama University. And the last, Professor Sahat M. Pasaribu from Badan Riset and Inovasi Nasional.
yeah. But first, we will welcome our first speaker, Professor Pantipat, that already joined us from the Zoom platform. Hello, Professor Pantipat.
Good morning.
Can you hear us clearly?
Yes. What about you? Can you hear me?
Hello.
Hello. Can you hear me?
Yes.
Is it connected?
Can you hear me?
Yes, we can hear you.
Okay. Thank you.
Yes, Professor Pantipat is the Dean of School of Agricultural Technology, Walailak University in Thailand. She hold her Bachelor Science in Suranare University of Technology, Thailand in 2002. And she held her master degree in food technology in the same university and held his PhD in Aarhus University, Denmark in 2013. She has published more than 90 articles since 2008. Applause. And her research interest in the field of food technology. Oke Pak Anci, kita mulai saja Kak?
Okay, yeah. We offer 20 minutes for Prof. Warawan.
Yeah, okay. Please, Mr. Professor Pampipat. Yeah, Professor Pampipat will present about edible coating for shelf-life extension for pre-processed fish during refrigerated storage.
Okay, time is yours.
Good morning. Can you see my PowerPoint? Good morning.
Morning.
Yes,
Can you see my PowerPoint?
yes, we can hear you clearly.
Okay. Good morning, ladies and gentlemen. It's my pleasure to be here. And first of all, I would like to thank the organizing committee for inviting me today. And I am so sorry to be not able at Indonesia. Today, I would like to share my research entitled Edible Coating for Shelf-Life Extension of Pre-Processed Fish during Refrigerated Storage. My talk includes the fresh fish quality and spoilage, and then a significance of edible coating for shelf-life extension of fresh fish. Then I will move to my research. First, I would like to talk about the whey protein-based edible coating combined with plant extract for shelf-life extension of seabass fillet. Then I will move to the starch phenolic complex and edible coating for mackerel fillet. And I will tell you a little bit more about my research in the combination of plasma-activated water soaking and protein-based edible coating for prolonging the shelf life of fish fillet during cold storage. And finally, the conclusion. Firstly, I will tell you a little bit about the fresh fish quality and the real orations. As you know, fish is one of the most perishable muscle food due to their rich in the nutrient and high moisture content. And generally, fish can be kept in the refrigerated storage in order to prolong the shelf life. Nowadays, ready-to-cook raw fish are widely consumed worldwide and kept in cold storage while being sold to consumers. Mostly, microbial decomposition and oxidative deterioration contribute to the qualitative degradation of fish or minimally preserved fish, which is negatively impact the shelf life of the fish. To retard the rate of the microbial and biochemical activity, the holder concept with low temperature storage has been used to fish and seafood products. One of the most hurdle technology that effective in prolonging the shelf life of fish is edible coating. Edible coating is the film forming solution or dispersion is an edible substance that applied thinly and directly on the surface of food. It is typically administered by spraying or immersing the item in the solution. The film serves as the barrier against gas and water and reduce the diffusion of oxygen and also regulate the growth of microbial and the enzyme activity during the storage of the cold sample. Normally, the composition of the edible coating affect the effective of the food, and we can improve the effective of the edible coating by incorporate the natural preservative into the film that can prolong the shelf life of the food and also promoting the health functions. Among the natural preservative, plant polyphenol possess the multi-bio function in inhibiting the lipid oxidation, the enzyme activity, and also they can inhibit the growth of microorganisms. And edible coating not only preserve the chemical and microbial quality of fish muscle, but it can improve the organoleptic attribute, which are most important of the consumer. I will move to one of my research that my master student did it. The whey protein-based edible coating combined with the plant extract for shelf life extension of sea bass fillet. Sea bass is one of the fish that consumed mostly in Thailand. And then we try to prolong the shelf life of sea bass fillet during refrigerated storage. We can, for the experiment, we have the uncoated sample. Then we coat the fish with the whey protein. And we coat the fish with the whey protein combined with the green tea extract, ginger extract, and lemongrass extracts. We monitor the growth of microorganisms, and we found that the whey protein with crude plant extract, especially ginger extract, can retard the microbial growth by maintaining the total microbial quality below the acceptable limit of 7 log CFU per gram for 15 days, whereas the shelf life of the control sample found to be only 8 days. And we also monitor the physical and sensory characteristics of the fish during the cold storage. For the pH, we found that the pH of the control gradually increased, ranging from 6.7 to 7.2 upon storage, whereas the fish fillet with the treatment had negligible change, suggesting that the efficiency of the coating in retarding the formation of basic compound, as well as the maintaining the buffering capacity of the fish fresh during storage. And for the change of color, we monitor the delta E. We found that the delta E of the uncoated fish tend to increase faster than the coated fish sample during storage, suggesting the efficiency of the coating. And we also monitor the hardness that determine the texture of the fish sample, and we found that the cold sample trend to slow the higher hardness than the control, indicating the textural preservative property of the edible coating. The fish coated with the whey protein with the ginger extract seem to have superior textural property throughout the storage period. We also monitor the water loss during storage, and then we found that the coating with the whey protein and phenolic extract can slow the loss of water during storage of fish in the cold storage. And for the sensory property, we found that the lightness score, including color, texture, odor, taste, flavor, and overall lightness of the cooked sea bass fillet evaluated at day 0 using 9-point hedonic scale. There are no significant difference among the treatments. For the chemical characteristic, we monitor the lipid oxidations that indicate by T-bar value, and we observe that the post sample had a lower T-bar value compared to the control samples. And there were no significant difference between the group, indicating the comparable lipid oxidation among the code samples. For the carbonyl content that indicate the protein oxidation, this was also found in at the same trend of the lipid oxidations. And for the heme oxidation, at the end, the high-end heme iron remaining was found in the fish coated with the whey protein containing green tea and ginger extract, suggesting this treatment had the most preservative effect against heme protein degradation. And for the methmyoglobin content, the formation of the methmyoglobin content was greater in the uncoated fish fillet than the coated sample. Overall, the coating with whey protein containing phenolic extract can retard the degree of lipid oxidation, protein oxidation, heme protein degradation, and methmyoglobin formation. For the off-flavor development, we found that the whey protein with ginger extract coating can markedly prevent the off-flavor development that indicate by the TVB and dimethylamine propanol contents. And we also analyze the odor lineage as well. And for another experiment, we use the starch phenolic complex to coat the mackerel fillet. And for the treatment, we have the uncoated sample at the control. And we coat the mackerel fillet with the starch solution. And also we coat the mackerel with starch solution combined with the different concentration of the manpu extract. Manpu is one of herbs in Thailand that consumed mostly in the southern of Thailand. For the microbial quality, you can see that the uncoated sample had a shelf life of only 6 days, whereas sample coated with the starch with 0.5% manpu extract extend the shelf life to 9 days by keeping the overall microbial quality below the permit level. And when you compare the appearance of the fish, you can see that the coating with manpu can preserve the color of fish during storage. And we also monitor the change in the lipid oxidation and propanol content, and we found that at all storage time, the cold sample, especially those with manpu extract, show lower T-bar value than the uncoated sample. And T-bar level in uncoated sample increased throughout time, peaking at 3.5 milligram malonaldehyde equivalents per kilogram at the end of the storage. To confirm the occurrence of lipid oxidation, we also measure the formation of aldehyde contents, and we found that coating alone can show extend inhibit propanol accumulation, but coating with the presence of manpu extract can in a concentration dependent manner can retard the formation of the aldehyde during storage. The lowest amount of propanol was found in the sample coated with 0.5 manpu extract, and is wrote at the concentration greater or lower than this one, similar to the T-bar content. And we also monitor the another quality change, such as the pH. And we found that the coating with the starch and manpu extract can maintain the sensory quality of the refrigerated mackerels. oh sorry, for the and they also preserve the textural properties in terms of water holding capacity and hardness, and postpone the development of flavor and odor, as indicated by lower content of total volatile bed or TVBN and trimethylamine as well. Therefore, the coating with starch and manpu extract, especially at 0.5%, can be employed to extend the shelf life of the refrigerated mackerel up to 9 days, as shown from the physical properties and sensory properties. And lastly, I will talk about my the experiment of my student. They combine the plasma activated water soaking and protein-based edible coating in prolonging the shelf life of fish fillet during cold storage. We divide our treatment into 4 treatments, and the control is the uncoated sample. And then we coat fish with whey protein and ginger extract. And then we soak our fish in the plasma activated water for 130 seconds, it's not minutes, sorry, seconds. And then we just soak fish sample with the plasma activated water, and then coating with the whey protein combined with the ginger extract. And we measure the microbial quality of the fish sample. And you can see that the total viable count of the control and exceed the acceptable limit on day 9 and on day 8. But when we combine the plasma activated water with the coating, we can extend the shelf life of the fish to 30 days. Throughout the storage, all three samples had a total psychotropic counts and a pseudomonas count below the permit level, with the total viable count exceeding limit at day 20. For the physical property, we just measure the physical property, chemical property, and also the odor development of fish sample during storage. And you can see that combination of plasma activated water and whey protein coating can reduce the off-flavor development measured by the total volatile-based nitrogen, trimethylamine, and also the propanol content, as well as the lipid protein and myoglobin oxidation compared to the control. And combination of plasma activated water with the whey protein coating reduce the discolorations, dip loss, and texture softening of the sea bass fillet, which was comparable to the plasma activated water and whey protein coating. Thus, the conjunction of plasma activated water and whey protein coating was an effective hurdle technique for extending the shelf life of ready-to-cook sea bass fillet. This approach was practical and industrially applicable. Finally, just the take-home message. The preservation of fish fillet was achieved by applying polyphenol-enriched edible coating. The edible coating with crude earth extract, especially ginger extract, can effectively retard the growth of microbial, lipid oxidation, and protein oxidation, as well as the discoloration of chilled sea bass fillet during storage. And the fish fillet coated with edible coating with earth extract was able to maintain the total microbial load below the acceptable limit of 7 log CFU per gram, roughly 1.5 to 2 times compared to the uncoated sample. And finally, the combination of plasma activated water soaking and edible coating in enriched herbs extract was shown to be an effective method for extending the shelf life of ready-to-cook fish fillet during cold storage for almost 4 times compared to the uncoated sample. I would like to thank you for your kind attention. Thank you very much.
Thank you very much, Professor Pantipat, for your nice presentation. But please stay there. Don't go anywhere because we will back for the discussion session after our the three of our speakers.
Yeah.
Yeah,
Okay.
Pak Encik?
Yeah. Okay, we will
Sorry, the committee.
Yeah.
They have very important another meeting there after this time. So do you mind if I leave, and then if the participant have any question, they can direct to me by email or another way.
Next 40 minutes?
I have the meeting, another meeting now with the company.
I think we can start our discussions, especially for Professor Pantipat. Maybe 1 or 2 questions from the audience?
Okay, please.
Yes. Thank you.
Yes, please. Please mention your name and your institution.
Thank you very much. I am Maria Vivarini from University of Lampung. Actually, I'm not in food science. I'm an agronomist, but this presentation also interested for me. In your presentation, you explain how to use the edible coating to prevent the fish to become deteriorate. My question is, why you use a protein and starch as a material for coating for fish? Maybe you can explain more because maybe I don't understand why. As far as I know, protein and starch is a carbon source that can be used by microbe to grow and develop. So in your study, you want to prevent the growth of microbe. So please explain why you use this 2 type of coating material. Thank you.
Yeah. Okay, thank you, Ibu Maria from Lampung University in Sumatra Island. And for the second question? Yes,
Yeah,
please, Pak Kadis.
Thank you. I think very nice presentation. I'm also not from the food science, but this is very interesting because we also have a traditional way in Indonesia, I think, how to preserve fish, but not fillet fish, but we usually preserve fresh fish. Yes, in your experience, Professor Purawan, in your country or maybe your experience, do you use turmeric? Because in Indonesia, we usually use turmeric and coriander, I think, to preserve fresh fish, and we can keep the fish fresh in the refrigerator quite long, I think. I think that's all. Thank you.
Okay, thank you very much. We already have two questions. And Professor Pantipat, can you hear the question clearly?
Yes.
Yes, please.
Thank you very much for the questions. For the first questions, usually we always use the protein and starch at the edible coating material because edible that means we need to eat the coating as well. So we use the protein and starch in to coat our food. For my case, we coat fish and we know that the microbial can grow very well using whey protein and also starch. So we need to put some natural preservative together with our coating material in order to retard the growth of microorganisms. So the first thing is we need to use edible material for coating food, and we generally use protein and starch in our fields, and of course we need to think about the growth of microbial. That's why I add the natural preservative together with the coating. And for the second question, turmeric is also used in Thailand as well. And we never extract the turmeric and add with the our coating, but I think it can retard the growth of microbial as well because the bioactive component in the turmeric can inhibit the microbial. But the thing we didn't use turmeric is the color of turmeric that may interfere the color of our fish, because we want to sell the mackerel and also the sea bass kind of the sliced fillet, something like that. And if we coat with turmeric, it will interfere the color of fish. So we didn't use, but I am so sure that turmeric can also effective to inhibit the growth of microbial. If we combine with the edible coating, it may have the ability comparable to the ginger extracts. That's all my answer.
Ya. Bagaimana Ibu Maria dan Pak Kadis? Okay?
Cukup.
Yeah. Thank you very much, Professor Panpipat, for your excellent presentation and insightful discussion.
Thank you very much.
Yeah, I hope you stay healthy and success in the future.
You too. Thank you very much.
Oke, Bu Nur, ya. The second speakers, ya,
Please.
Profesor Ivan Galis. Oke, applause,
Yeah.
please.
Thank you very much. Please sit down. Bisa ditampilkan CV dari Profesor Ivan Galis? Yeah, Professor Ivan Galis is a leader of research group in plants integration. He has traveled around the world to deepen his research experience from Czech Republic to Japan to Germany also, and also New Zealand. And his research area is in plant-insect interaction, plant stress and plant defense, plant molecular biology and physiology. He has published more than 80 articles since 1993. At that time, I was still a student and know nothing about scientific article for Scopus et al. And yeah, here are his current publications, most of them in not only about plant-insect interaction, there is also KTL for some loci associated with susceptibility to Asian stem borer. I think we will have interesting discussion for today. Okay, ladies and gentlemen, please join us to welcoming Professor Ivan Galis. And please.
Thank you so much for really warm invitation and introduction. I just have to say, okay, I was introduced as somebody who just traveled around the world. And I really, it's not like I really like traveling, but it's really finding a job in science. It's sometimes very difficult, but it really gave me a lot of opportunity to see many different countries, many different cultures, and I also learned a lot, I think, before arriving to my professorship in Japan. But today I'd like to share some of our research on plant-insect interactions. But some people ask me, are you entomologist? And I say, no, I'm plant scientist, because we are looking at the way to protect plants from insects. So we are just on the plant side. But before going into the scientific presentation, I'd like to just express my sincere thanks to the organizers and especially the rector of the university, Professor Abdunur, and also the dean, Professor Rusdiansha, and the vice deans, Bernata Saragi and Mrs. Nur Puspita Palupi, and of course the chairman, Dr. Samad Ramayana. So thank you so much for inviting me. It's my second time in Indonesia, and I really enjoy, I have to say, it's my favorite country to visit. It's so nice to be here. So now I will try to go into my presentation. I don't know if I can use to advance the slides. Maybe not. Okay, so why the herbivores are so important. So I don't think I have to explain here, because I think most of most of the people, participants, are working in agronomy or some agriculture related fields. So you can imagine that herbivores can damage plants just simply by eating the plant, because plants are the major source of the food. But we also have to realize that it's not only that the insects damage the plants by feeding, but the insects also transmit a lot of diseases. And we all know that the viruses, for example, are transmitted by sucking insects, which then cause a very large secondary damage. So if we say that maybe 1/5, about 20% of the yield can be lost due to insects, I think it's a huge number, and we can feed many more people if we can solve these problems. Next, please. So we can say that the application of pesticides is the main way to solve the problem of insects in the current world. But you also know that the insecticides can be very destructive, because sometimes they're not selective, and especially they're also very costly. So the application costs a lot to the farmer, and then they, of course, lose the income just because they have to protect the plant from the insects. So the question is the application of the insecticides is the only way how we can protect the plants? What do you think? Is it the only solution? Yeah, so I was very happy to hear the previous talk, because this was also using some natural products for the protection of the food, the fish in the market. So this is the same way, the same idea that we actually have to solve the problem. And the solution and the keynote message of my talk today is that nature is actually the most powerful, and nature already invented everything we need. All we need is just to learn from nature. Just if you go to the field, you can see differences between plants. Some plants are very susceptible. Some plants are very resistant. The question is why? So we need to just learn from nature. And I think we came to the age where the technology advanced very, very much. So now we have very powerful technology to analyze plants. We can look at the genes. We can look at the metabolites. We can do mass spectrometry. We can do everything. So now we have the tools, but we just need to learn. So we need really talented people. We need researchers. We need students. We need intelligence, okay? The artificial intelligence maybe will take over in 100 years, but right now we need people, trained people, and people just looking through, just keep their eyes open. And I think we can find a lot of solutions, and these can be actually applied to solve many of the current problems. So I just want to bring your attention to this slide, okay? So when you think about the insect, okay, so they eat plants, but then you have the insect like the brown plant hopper here, which only feeds on rice. So we call it a specialist. Then we have some insects which actually feed on a few plant species, like this small armyworm that can probably feed on rice and maybe some maize. And then we have a few insects which we call them polyphagous, which can actually use as a host, for example, corn, soybean, and cotton and rice, which is the grasshopper. So they can actually feed on few species. But if you think about it and you go in the nature, you go in the field, you don't find a single insect that can eat every plant. I think you have to admit that such insect does not exist. And the question is why? Why the insect cannot eat any plant? It's, it's all green and it's all nutritious. Why? So the point is, next please. The point is that actually plants are not just the victims. They are not just the passive participant in this plant-insect interaction. The plants are actually very active, and the plants evolved many, many ways to keep the insects away. So the insects also had to evolve. They had to kind of fight against the plant to be able to survive. And they evolved some counter defenses. So some of the insects, for example, learned, when we look here, the cutworm can actually feed on the oat because it managed to control or to deactivate the oat defense, which is the avenacin. Avenacin is a very toxic chemical, but this cutworm finds a way to overcome this defense. And then it can feed on this plant. But no other insect or the other insects with this toolbox cannot actually take advantage of the oat as a feed. Same for tomato. Tomato actually involves tomatin, another chemical which is actually very effective against insects, but some insects like the leaf miner can again overcome this defense and they can eat this plant. The corn borer, okay, corn has a lot of different defenses. Same, for example, as a pea plant, but the pea aphid can easily feed on this plant. So we have many, many interactions where the insect and plant co-evolved, and they made this relationship where this insect can actually feed on that particular plant. So our idea is, because we have so many different chemicals, we have so many tools possibly to control insects, we could use this, what we call natural plant defense, for protecting our plants. But now the main challenge is how we learn and how we apply this knowledge, okay? So without the use of pesticides, we could possibly change our crop in a way that it becomes a non-host plant for the insect. So if the insect can feed, for example, on corn, but we introduce some new defense compound in corn, this insect will lose the ability to feed on the plant, and therefore the corn will be protected by itself. It does not need any insecticide because it's self-sustained. I think it's the way of sustainable plant protection, a natural plant protection. We don't need any artificial chemicals to do that. So before going into the scientific part, I just want to mention something about the control of plant development and plant defense. So, do you know what is a transcription factor? Transcriptional activator, transcriptional regulator? I think everything we talk about now is about genes. So we have a genome, we have genes, but the genes, they're just a DNA, but they need some control. They need some way to say, okay, this gene should be switched now, and then the next gene should come, and the final, like senescence, the plant becomes yellow. It's also a controlled process. So these processes, for example, the cell programs, they are all controlled by transcription factors. Some proteins which tell the cell what to do next, okay? So they control development, growth, reproduction, senescence, and even death. You can program death, okay? So the point is that all these programs are controlled by the transcriptional regulators, but we also have plant responses to environment, which are also controlled by transcription factors. So once we can find or identify this particular regulator, we can actually learn a lot. Because if we switch off that regulator, we will learn about all the different genes that are involved in this process. So just now by the genetics, we can actually control, or we can knock out genes. We can very quickly learn about all what is downstream. Because if there is a river and you put a dam, the river will stop flowing. And then we can see what happens to the farmers. They don't have water, of course. So the same happens to the cell. It loses the control element, and everything downstream can be now clearly seen. So that's what we do. We do this very effectively. For example, if we look here, okay, so we have the herbivore, we have the insect feeding on the plant, and then this will be perceived by some kind of protein, some receptor, and then this will activate or control some transcriptional regulator, transcription factor, and this will trigger plant defense. So once we learn or find this transcription factor, we can actually learn how plant defense operates. So suddenly we can see all those chemicals, all those different elements of defense very clearly, okay? So actually we did this in the model plant. So we started on tobacco, and we learned about the tobacco gene. We call it MIP8. So it's just the name of one of the transcription factors, that when the insect starts feeding on the plant, so this is the control level, okay? This is the plant which is not challenged by the insect, but once the insect starts feeding, this gene is very highly activated. Suddenly this gene becomes very active. And then this activation actually continues for at least 2 to 3 days. So that means the plant activated defense. Now it's in the defense mode. Okay, so once we can knock down, so we have the technology to inactivate this transcriptional regulator, we can see what happened in the plant. And this is a relatively complex picture, but it's a chromatogram from the HPLC, and it's showing all different compounds in the plant which are produced. Okay, so for example, this rutin is a flavonoid, and you can see in this MIP silence, the inactivated plant, the rutin level is just normal. So that means this gene is not related to rutin. But we see actually two peaks here and here. They're clearly missing in the plant. So now we know that this transcriptional regulator is controlling these two chemicals. So when we look and we identify the structure of these chemicals, we can do that by mass spectrometry. We can see that this corresponds to this structure. It's called caffeoylputrescine and dicaffeoylspermidine. So it's a conjugate between the phenolic and the polyamine. And these two chemicals actually are triggered, accumulate in the plant in response to herbivore feeding. So that means they must have some meaning. This must be something important for the plant to do, to activate, accumulate these compounds, right? So then we can ask the plant itself, okay? Because we already have the plant which does not produce this transcriptional regulator, and because it does not produce these chemicals, we can ask the insect, in this case the Manduca sexta, next. So we can induce the plant, and then we just put the insect on the plant, and we see the performance, okay? How the plant defends. So basically, we see here that the insect, the caterpillar, will grow, okay, becomes bigger. At this rate, about 2 weeks, it will gain this weight. But when you look at the plant which was silenced, okay, that doesn't have this defense compound, suddenly the insect will grow much faster. So that means this compound is a real defensive compound. And if you knock it down by just taking off the transcriptional regulator, then suddenly you'll see that the plant will lose the ability to resist. Okay, so we learned that these chemicals are actually very important for plant defense. Whoa, the time is flying. So anyways, I just very quickly try to finish my talk by just simply saying that these defenses are just not happening locally. So when the insect is feeding in this part, it will actually lead to activation of defense in the whole plant, because the insect can move and it can actually feed on different areas. So the plant has to activate the whole systemic plant defense. So this is one of the very important features. So we can say that the plants can actually recognize the herbivore attack, and they induce production of defense metabolites, which are toxic to herbivores. And then this happens systemically, and especially in the important parts of the plant, like flowers. But I don't know how much time do I have for this presentation, but when I start talking, I just get too excited, and then I forget about time. So I'm sorry. So I just want to just go to the field of rice, because we can see here, there is a rice field behind us. So let's talk about rice a little bit. Just give me some time, okay? So in the rice field, actually, there's a lot of things happening, and especially we know there's a lot of damage, for example, from the grasshoppers and plant hoppers and brown plant hoppers and so on. So they not only cause damage directly, but also they transmit diseases. So we took in the field and we collected all these insects and we started doing the experiments, okay? So, for example, I talked about these conjugates, these polyamine conjugates, and we also tested rice plant. Does it produce these chemicals? And you can see that different insect, even the hopper, okay, will induce the accumulation of these chemicals. So they are kind of universal. So they actually not only specific to tobacco, but what we learned from tobacco, we can also apply in rice. That was really nice. But even though we focused on chemicals, in rice, I just have to tell you one thing, okay? In rice, the chemical defense maybe is important, but there's one more important thing that the rice is using to protect itself. Anybody has any idea what is the rice secret of protection? And the answer is very, very simple. Okay, so it just came from one experiment. Again, we just go to the field and we learn. So all we do is just looking in the field and going through the field and checking and looking at the plants, how they look, how they respond, how much they are damaged. And you can actually find some really amazing things. So we have this African rice, Nerika. And we just have this rice what is called Nippon Bare. It's the standard Japanese rice used in the experiments. And when we go in the field, suddenly you see that the Nerika plants, they're all very much damaged by grasshoppers. So the grasshoppers just enjoy this Nerika rice. So we just said, why? Why does it happen? Okay, there's just the rice. So why one is resistant, the other is not? And we noticed, because the damage was really significantly different, you can see all the statistics just show this Nerika is very, very weak. Why is it so weak? And we actually figured out one thing. When we used the electron microscope, we actually noticed that this Nippon Bare rice, okay, it is covered with these spikes on the leaves. They are really tiny. You don't see them by eye, but they are really tiny. And this Nerika, they don't have any spikes. And the Nippon Bare, even the seed, the flower is covered by the spikes, but here you don't see any spikes. So we went further and we just checked, are these spikes really so important that the grasshoppers just don't like the rice plant? And we actually figured out it is true. And it's because the rice trichomes are actually impregnated. They're very hard because of the incorporation of the silica. Okay, you all know silicon probably is an earth element which is very abundant. And this is actually the scanning picture of the silicon deposition and the silicon content. So while the Nerika can uptake silicon, it does not have the structure, the spike, to put the silicon inside. So it's just having normal silicon level, but it doesn't have the spikes. We also did a genetic comparison. This is the LSI1 plant, which cannot uptake silicon. So this is the other way around, okay? So it doesn't take silicon, but it has spikes. But look at this. It's too small, right? So this is the control plant, and this is the LSI1 silicon-free plant. And you see in the field, all the leaves, the green parts, are completely stripped off. So once you don't have silicon, the plant is lost in the field, okay? And the same for the Nerika. If the plant does not have the spikes, then it's lost. So you have to have the silicon in the spikes to make the complete protection. So this is just the story about rice. So the rice is also using the chemicals, but probably the most important part of rice defense is the development of these spikes. And they're very, sharp, and they remain. They cannot be digested. They cannot be destroyed by the insect. And inside of the insect, they cause damage. Because relative to the size of the insect, these spikes are really big. Okay? So I just mentioned one thing about there's another way the plants are defended. And this we call indirect defense. And this indirect defense is based on the parasites. So the plants can attract parasitoid wasps, for example, here. Okay, so this is the actual insect which was eating rice. And these are all the parasites that just come from the insect after a while. So when we go to the field and we collect these insects, actually up to 70% of these insects already have a parasite. So that means they are going to die. And how? Or because it's so important, the plants actually have the ability. This is the parasitoid wasp, and that is how it's controlled the cycle. But of course, the plants want to attract these parasitoid wasps because they are kind of like bodyguards. Okay, when you call them, they will come and they will take care of the herbivore. So the plants actually are calling for help. Okay, so the plants kind of talking to the environment saying, I have a herbivore, please somebody come and help me. And these parts that rest actually can smell the volatiles that are released from the plant. And on the long distance, they can localize the plant and they can come and help the plant. So this is really what we do. We just simply look at what chemicals are released from the plant and how they are controlled. And if we can increase the production of these chemicals, we can actually increase the plant protection because more of the natural enemies will come and protect the plant. And I have to really finish because I think I'm over time. And this is just how these chemicals are induced by the herbivore feeding. For example, you see this terpenoid linalool is very highly emitted after the feeding. Same for the other two chemicals. So we already know which chemicals are important. It's just we need to apply them. This is just the members, including Joaquin, who did the silicon. And I just want to say we have a big thanks to Kalis and then our friend, and he actually graduated in 2020 in my lab, and I was really happy to have him. And I will be very happy to have any other Indonesian student in my lab if you can come and get on.
Okay.
Sorry.
Thank you very much.
Ya,
Bagaimana Bapak dan Ibu? Masih semangat?
semangat ya.
Semangat. Tapi
Ya.
tidak percaya ya Pak ya. You don't believe your answer.
Ya.
How about if we check their enthusiasm in this discussion, in the next discussion?
Ya.
If we say, ICTAFF 2023, you should answer, recover together, recover stronger.
Ya,
Recover together, recover stronger. Okay?
Okay.
Okay. ICTAFF 2023.
Recover together. Recover stronger.
Once more.
Ya.
2023. Okay. No, we believe you.
Buna, Prof. Ivan's explanation about how plant defense to insect is very interesting.
Yes.
Yeah.
We should put our question
Yeah.
at the end of the third speaker.
The third speaker. Okay. So we are welcoming to Prof. Sahat Pasaribu from Badan Riset dan Inovasi Nasional.
Yes. Professor Sahat Marutua Pasaribu will join us from the Zoom meeting. How are you today, Professor?
I'm okay. Can you listen to my voice?
Yes, clearly.
Clearly? Okay.
Yes.
Can I share now my...
Yes. Okay, Professor.
Would you like to introduce?
Yes.
Okay, go ahead.
Yeah. We'll talk about economics of agriculture, and he is main researcher, a research professor in Research Center for Economics of Industrial Services and Trade. Yeah? Can you share? Okay, Professor Ibu, you can start
Yes,
the presentation.
Okay. Can you see my presentation here?
Yes, very good.
Okay. One moment, please. Okay, it is unfortunate that I could not join you there, especially as you have a very delicious snacks, I guess, during the break, and you enjoy the dance, which unfortunately I cannot hear the music, but I can see the dance. Anyway, I would like to thank everybody and greetings and good morning. I would like to extend my warmest congratulations on the third International Conference on Tropical Agri-Food, Feed and Fuel, and thank the Faculty of Agriculture, Mula Warman University, for organizing this important event. Especially, I would like to thank Professor Bernatal Saragi, who contacted me and communicated with me. I believe that all participants, including speakers and discussions, hope for a fruitful and beneficial outcome for everyone. Distinguished guests, ladies and gentlemen, my title of presentation is far from the first two. This is a rural development for a sustainable and resilient agriculture and food system. This is the title that requested by the organizer for me, and fortunately, this is actually also my field. So I'd like to discuss with you three issues after the introduction, and the last one would be the challenges and opportunities. Rural development, agriculture technology, financial support for resilient agriculture, and sustainable agriculture and food system are those three issues that we are going to discuss. Rural areas are identical with agriculture because food and other agricultural production are cultivated and grown in rural areas. Therefore, rural development also means agricultural development, which we need to increase to a certain level of achievement for a sustainable and resilient agriculture and food system. One of the SDGs goals is to end hunger through various efforts to achieve food security and improve nutrition and consistently encourage sustainable agriculture. This goal can also be responded by maintaining and increasing agricultural production to achieve security. However, for Indonesia, the challenge of increasing agricultural production clearly affects the development process. The government still faces many obstacles in dealing with the impact of global climate change, recovery from the COVID-19 pandemic impact, and the impact of high political tensions in various parts of the world, especially as we depend on the raw materials from these countries to produce essential fertilizers. Following technological development in the agricultural sector, the use of digital technology is highly appreciated. Farmers in this case need to adapt to a new era of agricultural practices because the government is looking for resilience. The use of technology to help improve cultivation, processing, and marketing activities is very helpful in overcoming many problems related to agriculture and its products. Rural development is accelerated by the use of such modern technologies in the agricultural sector. Keep in mind that the availability of agricultural financing to cover agricultural costs and other agricultural expenses is very important. Small farmers typically lack of agricultural capital, while the available formal credit is not easy to access. In fact, the government is also facing difficulties to improve agricultural infrastructures, especially the damaged irrigation systems and the application of agricultural mechanizations. We just talked about rice actually this morning. The importance of rice is increasing in importance because of the higher demand due to the population growth and also the improvement of income. In this context, rural transformation requires catalytic investment for sustainable and resilient agriculture. With this background, a key question regarding sustainable and resilient agriculture is how agricultural technology can intervene with current practices to improve their agricultural performance for better household incomes. Therefore, important insights from stakeholders on the complex problems associated with the agricultural sector are highly encouraged. This keynote message is prepared to look into current conditions while trying to find out ways to accelerate rural transformation and agricultural sector for a sustainable and resilient agriculture and food systems. Distinguished guests, ladies and gentlemen, The increasing level of greenhouse gas emissions amidst population growth have influenced global climate change, which causes water and energy scarcity. Currently, the impact of the COVID-19 pandemic is still vulnerable to the global food value chain, causing problems related to food availability, market intervention, and uncertainty in various aspects. Meanwhile, conflicts in Russia and Ukraine have to some extent disrupted agricultural production and food crisis in various parts of the world. With all these problems, agriculture is still a development priority, and the use of agri-tech is highly suggested for sustainable management of agricultural resources. Under this agricultural technology, the trend of increasing use of digital technology has provided a strong understanding of the importance of agriculture and rural financing in agricultural production systems for sustainable agriculture. To this point, the G20 communique in 2020, last year, emphasized, among the others, the following. Recognize the need of innovative technologies and good agricultural practices for sustainable growth. Secondly, note that opportunities to improve productivity in a sustainable manner lie in increasing responsible investment in agriculture and supporting innovative finance to agricultural technologies. And the third communique is encourage more utilization of digital technologies that complement, amplify the positive effects of other agricultural innovations and sustainable production methods to address the challenges of food security. In this regard, innovation and advanced use of technologies must be supported by appropriate investment in agriculture for resilient food systems. Indonesia is a country with a wide diversity of tropical products and important agricultural commodities. The farmers have experienced the development of production systems from subsistence farming to modern agriculture today. Smallholding farmers, however, mainly engage in food crops and horticultural crops, and this requires financial support and appropriate use of digital technologies. Agricultural technology enables increased efficiency of agricultural production, processing, and market opportunities. In this relation, rural development could be accelerated using such modern practices toward a sustainable and resilient food system. Recent experience shows that agri-tech can accelerate digital transformation and increase catalytic investment, especially agricultural financing for better agricultural performance. The application of digital technology contributes to strengthening the economic recovery after the negative impact of COVID-19 pandemic. However, implementing digital innovative solutions requires supports to improve infrastructure and farmers' capacity on digital technology with its innovative solutions to improve productivity, managerial capital, accessibility to market, and resiliency in food security. The role of Indonesia's startup agri-tech to deal with this approach is growing and developing, including e-fishery and agricultural finance for small farmers. Government and their development partners, of course, in this regard, are required to promote value chain investments through public-private partnerships. There are three main aspects of agri-tech in agricultural sector, namely the access to application of cultivation technology, capital financing, and marketing. The role of agri-tech startups through facilities and regulations are needed to strengthen the role of Indonesian agri-tech startups in the future. Ladies and gentlemen, the need for investment and financing in agriculture for productive economic efforts in rural areas is increasingly important. However, the financing orientation for small farmers must be adjusted to the benefit of farmers through simple procedures, easy processes, low costs, and timely according to farmers' needs. Most farmers experience problems in accessing working capital, such as KUR, formal credit scheme, which according to a report is not always easy to access. This condition causes farmers to depend on their own capital or on money lenders. The latter is easy to do, has fewer administrative requirements, it is fast, but is usually quite expensive because money lenders, without the awareness of the farmers, impose a lot of costs on the farmers' burden. Farmers' lack of working capital should encourage ways to ease this burden and provide opportunities for other stakeholders, especially the government, to take decisive action. In this regard, economic institutions operating in rural areas, agri-tech startups can collaborate with banks and open up opportunities for farmers to access funding sources. This is in line with the mandate of Law number 19 issued in 2013 on protection on empowerment of farmers, where small farmers have the right to receive financial and technical support. Economic institutions such as cooperatives, MFIs, microfinancial institutions, or other private companies that are in agri-tech startups of taker management partnerships can collaborate with farmer groups or farmer groups federations, not only providing technical assistance, but also advocacy to access sufficient funds for their agriculture. Agri-tech supports startups or off-takers are encouraged to develop their own businesses with independent creativity and disburse funds, business capital inclusively to help farmers. Collaboration between agri-tech startups or off-takers and farmers can be described in three elements, namely assisting farmers in technical matters in the production cultivation process, including access to production inputs. Then connecting farmers with funding sources, and in this case, banks, microfinancial institutions, cooperatives, etc., for capital, credit, and ensure marketing channels for farmers' products, direct purchase at market prices. Agri-tech startups or off-takers carry out economic activities in accordance with the mandate of Government Regulation number 81 of 2020 on agricultural financing, which can be implemented through a government-private partnerships pattern. Inclusive agricultural financing or investment in agriculture sector is highly recommended. Agri-tech startups, off-takers in this case, are those who have business legality and have the capacity to work together with farmers. The role of local governments in this context is very important in preparing the necessary regulations and accompanied by significant incentives. Harmonious communication between local governments and agricultural technology startups or owners with strong support from farmers will lead to sustainability and resilience of agriculture and food system. Ladies and gentlemen, technically, agriculture is unique according to the agricultural region. The performance of rice plants, for example, is influenced by local wisdom and the cultivation technique applied in farming activities. Rice farming in East Kalimantan, for instance, should be different with the culture of rice farming in West Java. Agricultural culture varies according to agricultural location. Therefore, extension approaches can also be adapted to local conditions. In this case, sustainable agriculture can also be influenced by agricultural practice traditions, customary actions, and the guidance of local leaders. Close social relations between agricultural stakeholders are also very important in the food system. Good communication between extension workers and farmers, for example, will automatically improve their social relations. This will ultimately bring mutual benefits because of their workability in the agricultural sector. The introduction of environmentally adaptive agricultural innovations through application of digital technology is aimed at helping increase agricultural production, increasing economic efforts, and increasing farmers' income. Meanwhile, to achieve higher crop production, farmers must comply with cultivation recommendation. It is very unfortunate that with a lack of working capital, farmer will almost certainly only implement recommendations that are less than optimal. Therefore, agricultural financial support is considered a critical point for improving agricultural performance. If we look back at the previous financial support situation for farming business, farmers have also experienced working capital constraints. This happened before 1964, when most farmers implemented traditional farming systems. In the Mass Development Program, we call it BMAS in 1964 to 1984, credit was introduced to farmers. A new scheme was then announced, Agricultural Credit, or KUT, Kredit Usaha Tani, from 1985 to 2000, where credit was available for rice, cassava, and horticultural crops and distributed through the cooperatives, Koperasi Unit Desa. Unfortunately, with poor management, this scheme failed due to the large number of farmers' debts, high non-performing loan. In 2000, the Food Security Credit, Kredit Ketahanan Pangan, was introduced to replace the Kredit Usaha Tani scheme. The Kredit Ketahanan Pangan is followed by a number of specific financial schemes, such as Kredit Ketahanan Pangan Energy for food crops, KUPS for livestock development, and KPANRP for plantation crops. These specific agricultural finance schemes were considered as helpful, very helpful, until it replaced with the new scheme, the People's Business Credit, Kredit Usaha Rakyat, since 2015. With several variations in KUR for agriculture sector, according to reports, farmers still face many constraints in accessing this financial facility. Farmers is highly recommended, but for some reason, most farmers have little opportunity to access credit from formal banks or microfinance institutions. Therefore, it is necessary to develop alternative schemes or significant methods that can meet farmers' expectations. The role of agri-tech startups, of takers in this case, is important to direct farmers to access funds and help them provide agricultural inputs to fulfill agricultural recommendations. With the influence of local governments, public-private partnerships can be developed. The food system is the interaction of elements along the food value chain, from input supply to production, processing, marketing, and consumption. And agricultural development is a prerequisite for a resilient food system and sustainable agriculture, which enables a resilient food system, assuming other elements also support advanced agricultural practices. To date, investment must be made for agricultural research and development with an orientation towards the application of advanced technology. In this case, agricultural and rural transformation based on digital technology is recommended, as well as strengthening cooperation between stakeholders. Distinguished guests, ladies and gentlemen, farmers are encouraged to take advantage of opportunities to increase agricultural capacity and improve managerial skill in one way to another. Farmers who are achieved in the public-private partnership pattern will take advantage to improve their farming performance. Agri-tech startups whose farmer groups use partnership networks can take the initiative to build communication with all parties while develop their businesses. Meanwhile, regional government need to be actively and consistently carried out outreach promotion and advocacy for inclusive agricultural financing. The government, central and local, provide various facilities to improve farming performance.
Professor Fahad,
Yes.
I'm sorry to announce you that your time is run out.
Okay. Can I just jump to the
Question.
It is only on 1 minute.
Okay.
Okay. Okay. This is 1 minute. 1 minute. The opportunities which could be potential to overcome the above mentioned challenges include availability and use of digital technology for agriculture and rural economic development, investment and financial support in production systems and post-harvest activities, agri-tech startups of taker with facilities and assistance in managing agricultural businesses, and symmetrical information to build sustainable economic partnerships. This international conference, where most the participants come from academics and scientists, is highly recognized. This is an arena created to exchange ideas while restoring friendship between stakeholders. With high appreciation for this conference, I hope that this event can produce more operational strategic recommendations and provide input for future agricultural development decision making, especially regarding the management of agricultural resources to increase the competitiveness of tropical agricultural food, feed, and fuel. With that closing statement, I would like to end this keynote address. Thank you for your attention.
Thank you very much. Thank you very much, Professor Fahad, for your insightful talk. Okay, menarik sekali ya Panci ya.
Yeah. Guna, because we have one more plenary session, maybe, for two speakers, yeah.
Yes.
I think this is the end of the first plenary session. But maybe we are waiting for one questioner from the audience. Please, 5 minutes. Yeah. Oh, there are two.
Okay, maybe we can open for two questions, but
Yeah.
mention your question briefly.
Okay.
Okay, thank you. My name is Lukman from Universitas Malaya di Bandar Lampung. So my question is for Professor Ivan Galis. If the herbivore insect already killed by something, what do you think about the environmental equilibrium? Maybe that is disturbance to the environment.
Yeah, I think it's a really, really good question because once we change something in the environment, there will be always some consequence. But what we are thinking is if we change very targeted property of the plant in one plant, then it's definitely less damaging than applying some pesticides or insecticide that will affect the whole range of different insects. For example, also the useful insects. I was just talking about the natural enemies, the parasitoids. I didn't talk about bees, pollinators, because we have many insects which are very useful. So in a way that if we only change, for example, rice and introduce one additional chemical, it will only protect rice. So in that way, the herbivores will not be able to eat rice plant, and this will be better protected. But it will not be spread. It will not affect the neighboring plant, or it will not affect the other plant. So we have to be always careful. So when we design a new technology, we should always look in the environmental context, because it's not just a simple one level, but we have different levels of interaction. So you're perfectly right. We should be careful, and we should always consider the broader aspects of the new technology. Yes.
Thank you. Okay. Please, Pak
Okay.
Rupi,
The second,
last one.
Yeah,
The
that
first
one.
session. Okay, thank you very much. Good morning. For maybe only question for Kelly Sensei. And uh, your presentation about management is very interesting. And I remember about theory about a talking tree in ecology insects by Peter W. Price. And in your material, many compounds can suppress insects and types of plants depends itself from insects. And in another study, uh, many endophytic fungi and bacteria endophytic bacteria can maybe in soil or maybe around around many inside many rhizobacteria and mycorrhiza.
Yes.
And my question is, do you know relations between many compounds in plants and another endophytic fungi or bacteria, endophytic bacteria influence maybe about relations. Okay, thank you.
Okay, I'm not sure I get your question exactly, but the talking tree hypothesis was made by Ian Baldwin, my former boss in Max Planck Institute. So I know a lot about this concept. But as you said, it's not only insects and plants, but we have also microorganisms, which are very important, and they also contribute to this interaction. So we, for example, found in one of our research papers that the bacteria in the honeydew of the brown planthopper. So the brown planthopper is secreting the honeydew on the plant. And these bacteria actually are recognized by the plant and can induce plant defense. So I believe the endophytes and all these other microorganisms also interact with the plant, but mostly microorganisms or to name more nutritious or more mineral or help the plant to recruit some nutrition. So, but this also helps plant defense because plant defense is based on resources. So if you have small budget, you can only make a small defense. So if the microorganisms can help the plant to get a big budget, of course we can afford more defense and more spending. So I think this is very important, and we can also introduce these microorganisms to actually help plant to defend against the insects. So exactly like you say, it's all connected. I think in my talk and in my life, I learned that nothing is just alone and everything is connected, and we should be actually looking at these connections and always consider the consequences. It also relates to the first question.
Thank you very much.
Okay, thank you very much.
Yeah,
Thank you,
Professor.
Dr. Fahad, for joining us today. We are very sorry because we have to limit the question.
Okay. Prof. Ivan, I think the plant defenses is the secret of the nature, I think. Yeah. Okay. Unfortunately, because we have limited time, yeah.
Yes.
So we apologize to you all, yeah, if we have shortcoming in conducting this first session. Okay, thank you very much for all.
Yes. Okay, give a very huge applause for our excellent speakers.
Siapa? Bu Nurul.
Okay. For the participants that actively involved in this nice discussion. We have a very interesting merchandise for you. Okay, we have Ibu Maria from Universitas Lampung, Bapak Kadis Mujiono from Mulawarman University. Kemudian Bapak siapa lagi Pak Enci? Dari Universitas Malahayati tadi Pak. Iya, silakan Pak, maaf Pak. Agak lupa ini, mungkin lapar kayaknya. Silakan Ibu. Kemudian kepada Bapak Rostiansyah. Iya. Iya. Oke. Profesor Ivan Galis, please deliver this merchandise to all of the participants that are already actively involved in this. One book, one person only. Ada. Pak Kadis, maybe we can give to him. Yeah, later. Take a picture? Yeah, take a picture together. We can also take a picture together. Ya, terima kasih Bapak Ibu. Ketemu lagi di lain waktu. Yes, maybe. Which one is? Yeah, silakan.
Okay. Thank you to Reverend Sana and please stay on the stage because we're gonna head over to the certificate please join us on the stage to hand over the certificate to our keynote speaker, Ivan Galish. Okay. Then we give applause to our keynote speaker, Prof. Ivan Galish, for the Queen's material. Baik Bapak, bertahan sebentar. Kita penyerahan sertifikat untuk moderator. Bapak yang pertama, yang penyerahan sana. Oke, baik. Sertifikat dia diberikan kepada Dr. Enci Ahmad Syafruddin. And now we take a picture together. Prof. Presidential, take a picture first with the Prof. Ivan Galish and the moderators. Okay, thank you, Dr. Presidential. Thank you, Dr. Mahasana, Dr. Enci Ahmad Syafruddin, and Prof. Galish. Thank you so much. And now, we're going to our second plenary. We will invite Prof. Sunayo, Please join us on the stage.
Give applause. Baik, berikut adalah CV singkat dari kedua moderator hari ini. Yang pertama adalah Bapak Profesor Sunario SPMSI PhD, Professor in Plant Biotechnology, Faculty of Agriculture, University. Bachelor degree in London University, 1997, and then Master degree in Biotechnology, Institute Pertanian Bogor, 2002, and then Doctor in Plant Biotechnology, University of Göttingen, German, 2010, Research Interest Plant Biotechnology.
Okay, the second moderator is Dr. PhD, Professor in Plant Nematology, Faculty of Agriculture, Maryland University, academic background, PhD in Plant Pathology, University of the Philippines at Las Vegas, 1994, Magister Science in Crop Science, Gajah Mada University, 1988, Engineer in Crop Protection, Maryland University, 1983. Research interests, integrated pest management, second, integrated farming system, and the last is alternative food crops production. The Prof. Suyadi and Prof. Vidi Sunario, time is yours. Okay, sir. Okay, thank you for the second plenary. We have two speakers. Yes, Pak Yadi, we have the first speaker is Profesor Nurmas Wana binti Ismail from the Faculty of Economic, University Putra Malaysia. So we would like to invite Professor Nurmas to the stage, on the stage. Okay. Give applause for Professor Nurmas. Second speaker is Dr. Odit, is the Associate Professor in Faculty of Agriculture, Maryland University. Is now very challenging researcher from our faculty. Please. Professor Nurmas, please go on stage. To do outside. Okay. So we have to waiting for the moment. Aku yeah, for times limiting, we invite the Dr. Odit for the first presentation, I think. Okay. Okay, so we can please Dr. Odit, but I would like to read a very short CV of Dr. Odit Kurniadinata. Dr. Odit Kurniadinata graduated from IPP University for the PhD, especially in the subject of agronomy and horticulture subject. And he is now very active in research in fruit physiology, pomology, and also paludiculture. Okay, I think time is yours, Dr. Odit.
Thank you very much, Rob CID and for this scenario. Good morning, everyone. I'm so sorry because there is something problem outside. So this is I need to prepare it. So thank you very much, Prof. Suyadi and Prof. Yudhisnario. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Allow me to explain, please, in front of the stage. Prof. Ivan can show my presentation. Okay, still wait to the operator. I would like to say that this is a part of my research, and just like what you can see that I'm the only one local person here among all of the keynote speakers. So I will tell about the research that I done in this province. So I want to talk about strengthening the taro plant potential in Central Mahakam, East Kalimantan. This research is a part of paludiculture research in peat, swamp, and tidal ecosystem in East and North Kalimantan. Next. Okay, next. Okay, just like another keynote speaker said that the COVID-19 pandemic give us a negative impact. So that's why I also want to mention it, because the post-COVID-19 pandemic and climate change issue is forming us to accelerate our agriculture system to be more effective, more efficient, and sustainable. And also FAO said that in 2015, the world population expected to reach 9.7 billion, which 70% people will live in cities. Okay, next. So when we do some research, Professor Fasaribu last mentioned that the rural farming is unique based on the region. So that I agree with that. So that if we want to do study in the region, especially for rural farming system, we need to know the typical of nature environment. With this research idea, we need to know the typical nature of East Kalimantan. East Kalimantan, the climate is unique. We have a humid tropic which have high rainfall throughout the years, low solar intensity, and high humidity. And also generally rural agriculture is without irrigation. And then our land is, most of them is a peat, tidal, mineral soil low, pH, and also potential oxidation by period, and utilization of lake water or river water as the main source of water. And I need to mention this, Mother Nature is part of life for local people in East Kalimantan. So this is important because they live with the Mother Nature. Okay, next. So our team has have two ideas to develop rural farming in Kalimantan. First, we need to focus on the community, and the second is we need to focus on the product. Okay, next. What is we do with two ideas? First is we need to know the culture, because just like I said before, when we talk about the rural farming system, the culture is very unique. So the culture of the local people and also the immigrant is different. And another thing is we need to know about the human resources gap on between young and old generation. And also we need to know about the support, including partner, government policy, research institution, company, etc. And then we need to go to the potential, skill and knowledge, and land and ability to manage lands. Prof. Monas,
Please to the stage, Professor Normas.
I'm sorry, I need to present first before you. Okay, I continue my presentation. And the last thing we need to know about the land and ability to manage lands. Okay, next. And the second idea is we need to focus with the product. You know, in the rural community, the access of information and technology is very low. So we need to know
identified where's the access, how the access, and who is can get the access, and also about the demand and potential, because maybe in that region they need it. They need that product. The demand is high, but the potential to improve it cannot be allow it. It cannot be work there. So we need to know the demand and also the potential of the product in that region. And the third is we need to know the price about the product. Is edible for the people or not? And the last thing, we need to know about the market. Okay, based on the two idea, we move our research. Next. This is the overview of Paludiculture team of the Agriculture Mulawarman University. Next. This research is started from 2018 when we collaborate with the Ministry of the Environment and Forestry. We did a canal blocking, and also we making agriculture and fishery demonstration plot. And at 2018, we found a unique crop. It's called purun, and then we improve it. Purun plant as the organic straw. It starts from 2018. 2019, we still work with the same collaboration with the Ministry of the Environment and Forestry. And then 2021, because to 2020, there is a pandemic. And 2021, we start again research. And right now, 2023, we collaborate with some agency corporation is GIZ here. Okay, next. So our partner is list on the slide. I don't want to tell because the time. Okay, next. So what we already done with this research is we identified unique crop in the rural region in East Kalimantan, especially in the Middle Mahakam. We found the purun plants. We found some taro plant. Also, we improved the floating rice system, and also we do some research right now about the lotus plant. But in this session, I want to tell you about the taro plants. Next. So taro plants, we identified this is number of parameter from the carbohydrate source until all of them, biodiversity, habitat condition, morphological identification, and so on. Okay, next. So this methodology is we done with the identified inventory and characteristic taro plant species in the Central Mahakam region. The morphology used the UFOX guidance, and we carry out at 3 regions, namely Minta Village, West Kutai Regency, Lebak Rinding Village, and also Tuanatuha Village at the Kutai Kartanegara Regency. Next. This the result of the taro species inventory in each village. At the first village, Lebak Rinding Village, we found 4 kind of species of taro: Alocasia macrorhiza, Alocasia indica, Colocasia esculenta, and Colocasia esculenta var antiquorum, with the local name Lejong, Birah, Keladi, and also this is the habitat. This we found maybe it's cultivate or still wild grow. We checklist here, and also there's additional information about what the unique of this plant. So in Lebak Rinding Village, we found 4 kind of taro. Next. The second village, we found 7 kind of taro. For kind taro that we already find at the Lebak Rinding, we also find in the Minta Village, and we additional get another taro species. It's Santosoma sagittoforium, Colocasia esculenta, and also Colocasia esculenta. 6 and 7 this is a same species, but we still work with the identified the cultivar because there is the different the color of the stem. You can see the sixth crop is has purple leaf bones and have a purple spot on the center of the leaf, and the seven is like a pulut taro, purple stem color, and the higher is about 1.5 meters to 2 meters. Next. The third village, we found 9 kind of taro, from Alocasia macrorhiza, Alocasia indica, Colocasia esculenta, var esculenta, Colocasia esculenta var antiquorum, Santosoma sagitorium, Colocasia gigantea, Colocasia esculenta, with the different cultivar. And this is the local name. So much of them, the local people said as a kladi, because a kladi means it's like, for vegetable crop, vegetable food. They just need to eat a little bit, not as beneficial or industrial mindset. So most of them is wild grow. Okay, next. Okay, this is how our team identified the kind of the taro. Okay, you can just see, and we can next. Colocasia esculenta, we can find in the 3 target of the village. Okay, next. Next. We found at the Lebak Rinding. Lebak Rinding, we found 2 varieties of the Colocasia. First is the green stem and with the purple stem. Both is the people cultivate it, but some of them is still grow wild. You can see this. And then next. Also, we can find the Colocasia esculenta in the Minta village. Most of them is wild grow. Next. In the third village, we also find the Colocasia esculenta. Some like the 2 villages, they much of them is wild grow. Okay, next. Another taro we found is Alocasia macrorhiza. This is the bigger taro, which can grow up to 1.5 meters. And most of people don't eat it because Alocasia macrorhiza plant contain calcium oxalate, so it's getting ill when we eat it. But they just live. So I think this is interesting if we collaborate with Professor Ivan Galis, because this is a wild grow plant. They don't, and this is a low attack of pests. I don't know why. When we take it as a cultivated plant, there is much of the grasshopper and caterpillar leaf, but when it's still wild grow, there is no grasshopper, no caterpillar. I don't know why. Maybe your research being the answer. Okay, next. And then also we found Alocasia indica. This is like Alocasia macrorhiza, but more skinny. And this is a tall plants. Compared to macrorhiza, this species is not edible, so we cannot eat it. And most of them is used as ornamental plants. Okay, next. And then finally, we also find the Santosoma sagitorium. This plant we found at 2 villages, Suanatuha and also Minta village. This plant is edible. Okay, next. This is the picture how we done with that all of the research. So you can see all of the kind taro is from small till to the bigger one. We can find at the Mahakam Tengah region in East Kalimantan. Okay, next. And also we make a laboratory analysis about the nutrition content for the 9 kind taro. You can see here. And next, we found out the moisture content, ash content, and then fat contents, and then next total sugar, sucrose, and also reducing sugar. And next. Oops. Wait, what? Okay, here.
I'm Dr. Audit.
Okay. As you can see, the nutrient, especially about the carbohydrate and also starch and crude fiber, is very value for development, because the carbohydrate high, starch high, and also the crude fiber is high. So this is a potential for substitution of the another crop carbohydrate source. Next. Okay, because the time. So we suggest some development potential. Next. We do with some technique about for hospice processing. Next. And we make it flour from the comb of the taro. Next. And also we make a taro chip. Next. And right now we work with the leaves, stem, and comb. You can see this is the stem. This is very high, vigorous leaves. This is potential for cigarette, tea, animal feed. Stem is potential for animal feed, woven, organic fiber. Comb is edible for fresh flour and chip, all of the food. Okay, next. And yeah, I can say that we found 9 types of taro in the East Kalimantan, and all of this taro is potential to develop it. Okay, next. And additional notes, we also find the caladium, but it is not edible, just for the ornamental plant. Next, just a minute, Prof. Siyadi. This is some documentation, our activity, and we collaborate with the NGO and also the local communities, including the village chief. Next. Our next project is we want to identify much of the unique crop in Mahakam Tengah region. You can see we found much of the plant that in this year or next year we want to do this research about identify and explore this plant. Next. We also already make a organic straw. And this is a collaboration with GIZ. There is the person from GIZ, I think, here, and also they develop the floating rice system. Next. This is the woven from Purun. Next. This is the research time member of the Culture from the Agriculture Mula Warman University. And next, I want to thanks to the maybe it's past one slide. I want to thanks to the Faculty of Agriculture Mula Warman University and also to GIZ, the Germany Agency for Cooperation for Indonesia, to make it possible do this research in East Kalimantan. Okay, the time I give back to moderator. Thank you very much.
Big applause for Dr. Afif Kurniadinata. If you have some question, I think please hold after the second keynote speaker, and I will read the very short CV. Professor Nurmas Wana Binti Ismail. She is the Timbalan Dekan, Vice Dean for Research Funding and Corporations. She has also 88 very prominent articles published in reputable indexed journals.
is very great. Give an applause for Professor Nurmas. Graduated from School of Economics, University of Southampton, University of United Kingdom. Okay, I think we can give a time for Professor Nurmas to give a presentations.
Okay, time is yours. Okay.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. First of all, I would like actually to extend my appreciation to Professor Abdul Noor, Rector, University of Mullah Warman, Professor Rusdian Shah, Dean of Faculty of Agriculture, and also Vice President to Vice Dean Prof. Benatal Saragi, and also Mrs. Nurul Puspita Palupi, and of course to the Chairman, Dr. Shamat Ramayana, Chairman of International Conference on Tropical Agri-Food, Feed and Fuel. So thank you very much for inviting me to share some of my research, because I'm not agricultural scientist. My research is more on the economics. I'm economist. Specifically, my research related with the international trade. But because I have experience as a Deputy Director at Institute of Agriculture and Food Policy Studies, and I did quite numbers of research related with the food security. But today, actually, I would like to share with you is a very important message that related with international trade. We heard nowadays, because of the rice is not enough. Okay, we thought that we can produce our own rice, but and yet we are actually importing most of our foods, including rice. So this is what actually I try to relate. What actually the relationship between international trade and also food security, when actually the issues and also challenges that we're gonna look at. Okay, so I will start try to deliver understanding about food security. I think most of you maybe already know about the food security, but I try to relate where actually the international actually is a part of component in the dimension of food security, and straight to international trade and food security, and try also to look at the issues and challenges and what actually the takeaway notes. Okay, let's actually look at in the global stage. The global food security, if you actually look at this graph, 700 to 800 million people were affected by hunger in 2021, and it increased during the COVID. So this is actually very serious. And if you look at that, increase by 10%, so it's a lot. Okay, so look at the maps here. Surprisingly, if you look at that, this is FAO hunger maps. Surprisingly, the data tells us that 425 million actually in Asia is affected by hungers. So we thought that we are the second. No, we are the first in Asian countries. People actually got hungers most. And so this is actually when we actually try to zoom. Okay, more than half of the people in the world affected by hunger actually is here in Asian countries. Okay, so we know that this is the SDG goals. There's a 17 goals. Okay, so one of them actually is to have zero poverty, zero hunger. However, around the world, about 30% of the global population actually have moderate or severely food insecure. Right? So that is why we need to understand what actually the food security is all about. Okay, let's try to understand what actually is a food security. Food security, by definition, the food, when all people at all time have physical and economic access to sufficient, safe, and also nutritious food that meets the dietary needs and food preferences. However, in 2017, what we noticed, FAO, the the Association Food Agriculture and Organization, and WHO, the World Health Organization, they are actually together. These two important institutions, they work together in terms of monitoring food security. Why? Why WHO actually is coming into the picture? So if you look at that, there's a 4 dimension in food security. The first one is food availability, food accessibility, utilization, and food stability. Let's look at the first one. Food availability. If you look at this chart, under food availability, there's a domestic production, means that we need to produce our own food. And if we don't have enough domestic production, so we need to import. So this is where the importance of international trade is coming in. We import the food. And in some of the countries, when they have natural disasters, so they actually receive the aids. We call it food aids. So basically, in the theory of economics, why actually we import? Normally, we don't have enough food at home, so the supply is less than the demand, so therefore we can import the food. Okay, so in Malaysia, we measure in terms of the domestic production based on the SSR, self-sufficiency ratio. Okay, if this is SSR, so this is where we look at in terms of whether our domestic production is enough or not. Okay, according to this chart published by Department of Statistics of Malaysia, in 2022, I take the example rice, because we talk lots about rice. SSR is about 62.6%. So this is not enough. Our domestic food, we produce our own rice is not enough, because when we look at the second chart here, this is actually PCC, per capita consumption. Per capita consumption in Malaysia is 77.8%. So we don't have enough rice at home. So that's why we need to import rice. The second dimension, we look at the food accessibility. Food accessibility is very important. Especially in economy, we look at the economic access. It means that the household, they have actually should able to buy the food, to purchase the food. All right. So therefore, in economy, we don't measure gross income. We look at real income. What the meaning of real income? So real income means that the income divided by price. So imagine the food price increase. So the real income actually is a decrease, shrinking. It means our household, they can buy less food. Because of, not because of the income decrease, no, because of the food price increase. So this is very important, how actually we can make sure that the food actually is stable, the food price is stable in our economy. Okay, and another accessibility, actually infrastructure. Okay, it's very important, especially to those that actually stay in the remote area, how they access the food. Whether the road, there's a transportation to get the food. Right? So otherwise it will be not secured. The third one is food utilization. Next. Okay, food utilization now actually is under monitoring by WHO. Okay, so what actually you observe here is based on dietary. So utilization, consumption of food should be have adequate in terms of dietary, should actually use clean water, sanitation, and others. However, the monitoring by WHO actually looking at the malnutrition for the children, for example. Okay, so you can see here the blue bar here is a stunting. In the global stage, stunting actually is alarming. Bantut, bantut in Malay what we use. So and also the women, okay, so tend to get anemic, anemia, and also obesity. So this actually been monitored by WHO because it will cost us in the future. The future will be costly if we actually have the having this kind of problem in the our okay. So this is another cause of the obesity and others non-healthy food. So let's look at the because of nowadays actually are moving toward urbanization. Okay, I come across with two term, food swarm and food desert. Food swarm is where the food actually the healthy food is available in the urban area, but there's also lots of abundance of non-healthy foods. Whereas
Recording stopped.
Okay, so this is actually the top major exporters of cereals, the US, Russia, and the major importers is China. All right, so look at rice. So this is actually where the rice actually been import and also export worldwide. Okay, so if you can see that, of course, rice actually the major exporters is India, India, Thailand, and also Vietnam. All right, so all right, now let's actually let me connect the trade policy and also the food security. If you look at, for example, the right hand side, okay, moving towards free trade. So free trade actually you are easily to import and export everywhere, anywhere in the world. However, if you look at the left hand side, when they are actually moving towards protectionism, so it means that the country actually imposing the trade policy. Trade policy actually is a very important, it's kind of trade barrier, but it's very important for the countries, especially related with agricultural products. Okay, so there's a two type of trade policy. The first one is tariff, but tariff actually will give a higher import of the price. And a very popular one actually is SPS, sanitary and phytosanitary. Okay, so this is food safety for animal and plants for the health measures. So sometimes the country, they use SPS to protect their own plantation, for example. And so that's Prof. Even actually mentioned about the disease and also the insect, right? So this is actually why the country, they put the trade policy as a measurement, trade measures for the SPS. And the recent one, this is among the recent one that actually we can see that some of the producer countries, they are prefer to use export restriction to restrict the exports. All right, so limitation of the quantity of good exported to a specific country or countries by a government. So take the example when India actually imposed export restriction on rice. Started in June, July. Okay, so you can see that it's everywhere in the newspaper, right? So India actually export rice to many countries. So you can see that India actually export more than 30% worldwide. Imagine that India put the restriction or ban for the export of non-basmati white rice. Started in July 20th. So India actually, when they actually put the ban, so definitely a country like Malaysia, we depend so much on the rice from India. Okay, so the stock or the supply in the domestic is not enough, right? So definitely will actually affect to the price of the rice. All right, so this is Malaysia. We import in several countries, including India, and 30% we import from India. Right, so and this actually is a very important when actually India put the ban on our rice. And why? So we need also to know why actually India have to put the ban on the export, because India use trade policy, restrict the export because of they wanted to ensure the consumer in India enough rice. Okay, enough stock of the rice, because they wanted to ensure the food security for the countries. We cannot blame India, but
Time, please.
almost, yeah. So 2-3 minutes, yeah. So when you look at that, India actually banned because of nowadays, if you look at that, the climate change. The climate change actually, what actually we observe from El Nino recently. Okay, the last for El Nino actually showing that India actually received lesser and lesser rain. According to my study, I put in the modeling, strong El Nino lead to decrease in the rice production, right? So, and this is actually happening now. So, and other than that, because of the related with the war also, geopolitical crisis, Ukraine and Russia. Okay, so you can also observe that the disturbance in the supply chain during the war, especially for the fertilizer, for the ingredients, all right? So, and export restriction also happened to the chicken in what time? Okay, so the price of chicken in Malaysia is very expensive because of that. And for your information, the globally, our arable land actually is shrinking. All right, so it's shrinking is less than 5% in the global stage. And this is also very important. We are not only facing the food security, but we are going to face also the water security and also energy security. All right, so, and of course, the issue of climate change. Okay, so it's just that I want to highlight that how actually we can secure our own foods. Okay, so because of someone mentioned about the technology just now. Okay, so definitely that the smart farming can increase in terms of productivity. So I would like to share one case in China. Okay, so in China they use, so this is, okay, AI. We can use AI, can use drone. Okay, you can use the robotics. But what actually is a very important to share with you is how actually, okay, this is also another, you are scientists. Okay, maybe this is actually, now we can use this, that drought resistance using GMO. So I think there's a lot of study being conducted to apply in the African countries to use GMO so that they actually drought resistance. And the last one actually to okay, this one. This is very interesting. Maybe, okay, we can actually apply in our own country. They just started to develop digital village. So maybe this is actually one takeaway notes that maybe we can think about it to solve the food security. We can digitalize, but not in the urban area, but bring it to the village. So thank you very much.
Okay, big applause to Professor Normas. Thank you very much. Two presentations.
Dr. Odit and Prof.
From Prof. Normas.
Yeah.
Yes. In Taro exploration and identification, and also international trade for agricultural products. So, Prof. Suyadi, now we will
discuss from Dr. Odit. It's about the alternative foods, I think, and security foods from Prof. Normas.
So, but it's interconnected. Yeah. Very interesting. So now we will open the discussions. Maybe 10 minutes. Okay. We still have 10 minutes.
Yeah.
We'll open question first. Okay, please. Yes, Dr. Suhardi first, and yes, from Papa Lampung. Maybe Dr. Suhardi first. Dr. Mahawi, sorry.
Assalamualaikum warahmatullahi wabarakatuh. Thanks a lot for me. This statement maybe question addressed to Prof. Normas. Food security is very important. It's related. It is closely related to the national stability. And what do you think about the politics related to the food security? Because it's in Indonesia especially, is related. National security is closely related to national stability. What do you think about this? Thank you.
Very interesting question about yes. Maybe directly to the second question first. Yeah.
Okay, thank you. My name is Ing Lukman from Universitas Malahayati, Bandar Lampung. Well, I think the trouble in India is maybe it's blessing in disguise, because recent hatred politically from the Indian government to the Muslim, is very intimidating. So I think the blessing in disguise is like this. The Vietnam is very high in the rice production. Even Indonesia import from Vietnam. And I see in Malaysia so many idle land. The paddy field so many is not active anymore. So maybe Malaysia should be started to plant paddy, to make a paddy fields activity again. Okay, thank you.
Okay, two questions. This addressed to Professor Normas, but maybe later Dr. Odit can also give additional information.
Okay. Thank you for the questions. Okay, when you talk about the political wills, all right. So of course, definitely that when we wanted to determine the policy is very much related to a political issue. So even though the economic structure that's, for example, like in Malaysian case, we actually used to be agricultural, driven economy. So however, in the past, 70% actually the agriculture contribute to the economy, but now less than 10% the agricultural contributor. Why? Because the policy actually changed, looking at the manufacturing and also the services sector. So when a decision actually to move from agriculture to manufacturing sector, what actually the decision and policy that they use import actually is much more better, because if you look at that, the price of import is much more cheaper rather than if we produce it by ourselves. So this is actually the old thinking. Okay, the old actually school of thought. Okay, when we actually agree that the food import is cheaper, so therefore we import is better. This is actually the mindset that in the past. So to me, actually, it's a very big mistake when we we reduce our agricultural sector and we are actually started to import our food. So because all the innovation and technology, research and development move towards the manufacturing sector and not the agricultural sector. So that's why we are very convenient that importing actually is better than produce ourselves, but not when we talk about, when we look at in 2030, okay, for our SDG goals, I can foresee that. Okay, so this is the time that we have to forget about the food import. If for the staple food, we need actually to ensure that we produce our own good, especially for the rice. If the rice is not enough in our own country, we need to think about what actually the second and the third alternative of the staple food, so that our food is secure. So this is, again, when we talk about the political wills, okay, so that's also very important, how actually the vision the future. So we are not talking about the current, we are talking about our generation, the future generation. So imagine that you can imagine that Singapore, they are actually a country that they don't have arable land. But what actually the strategy by Singapore government, they put the investment in the other countries. So, for example, they invest in the vegetables in Malaysia. When they invest, they are part of the owners, right? So definitely they secure the food. They produce in Malaysia and then they export back to Singapore. That's the way they secure, because they don't have the arable land. But a country like Indonesia and Malaysia, political, of course, they have their own political way, but the vision that they wanted to see, not only the current, during the political time, but they have to see for the longer vision. Okay, not only 2030 as SDG, but actually longer than that. So thank you very much. In the case of the Indian case, so that actually is a political also, because the government in India, they also wanted to campaign. Okay, they actually concerned about the local citizens. So that's why they said that, okay, we don't want to export rice. So last time they put the restriction in onion, but onion I think still okay in some for importing countries like us, but not rice. Rice actually we will actually stop. We don't eat rice. So that's why I'm thinking about suggesting that we have to look at the other staple foods. Taro. Yeah. The ubi kayu. For example, sorghum. So I think this is actually moving forwards, that a country like us, in Asian country, we need to identify the next step. Thank you.
Mungkin comment from Dr. Audit. Thank you very much, Rosedi. In this case, I 100% agree. Yes, there's an old statement that if our food is full, the heart is calm. So I think we need to improve our agriculture sector, especially for the rural farming system. We need to hit the rural farming system and also rural farming community, because we need to eat, right? When we don't have to eat, so everything will be confusing. But when we realize tomorrow we can still eat, so we will come.
So that's why I agree with Professor Normas. So I think I can just edit information about that, and I 100% agree with you, Prof. Thank you very much.
Okay, I think we have the limit time.
Maybe one.
Okay,
One more
we
question.
offer for one
One more questions. Okay. Now, Dr. Zuhadi, please. Yeah, Dr. Zuhadi.
So thank you so much for the chance. I would like offer question to Dr. Audit, I think, because I'm really interested with the tarot. You already present about the tarot. Dr. Audit, as we know, the tarot is we can find so many species and family of taro in Kalimantan Island. But some of taro is toxic, especially in the root, the content of the calcium oxalate. What do you think about this? Based on your experience, how to classify which one is toxic and which one is safe for our food? Thank you so much.
Okay, Dr. Adit.
Okay, thank you very much, Dr. Actually, yeah, taro has calcium oxalate. Calcium oxalate is shaped with the crystal of calcium, right? So this is a little bit little. So when it touch our skin, is getting itch. So we do the treatment for the with water and also wash it with the salt, and it can reduce the calcium oxalate. And then we make it. Yeah, I got the bad experience with this. I trust. I mean, I need to tell you that at the first time I tried to eat it, 2 days I okay, that is not feel it's very uncomfortable in my mouth. So I try, and our team try to find out how to reduce the calcium oxalate effect. And right now we are, maybe it's not 100% is calcium oxalate will be gone, but yeah, we can reduce it. And each feel is better. I mean, I think we cannot feel it when we make it as a flour or cake or something like that. So it is, I think this is safe. Yeah, but I suggest you that we cannot eat it raw material, because this is a very itchy. You will feel pain on your mouth. I already tried it 2 days. I cannot eat. I can eat nothing. This is a very bad feeling. So we can later, Dr. Hardy. Thank you very much.
Okay, I think time is over now. And big applause for two keynote speakers, Professor Nurmas Wana Ismail and Dr. Odit Kunyadinata. And on behalf of the moderator, we would like to apologize if we have any mistake, and we would like to end of these sessions
because of time limit.
And wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam. Certificate. To summarize, give a online certificate to pelayanan kandidat dan kesehatan SMB. To and kesehatan SMB. Are you still on the Zoom meeting? Can we show the saat masa ini.
Yes, I'm here. Yes, I'm here. Can you hear my voice?
Very good. Thank you very much. We provide certificates by online to officers at Costa Rica. Thank you very much for the very good presentation about the exile food security, especially in Indonesia. And I hope so the next time we meet again to discuss to the future about food resilience. Thank you very much for your side.
You're very welcome.
Okay, please thank you. First, and also, thank you very much to Professor Panuvat, especially you talk about the food, especially how to manage our health, and especially to the function of another food to make our body health. Especially functional food items and how to cover together and commercial and breeding sustainable and silent agriculture in the world. Thank you very much to Professor Goran and Fanifas. Thank you very much. Okay. We're looking next to the participant in the application kepada saya juga kita akan serta silakan kepada informasi and also from Udi Malaya in Lampung. Please to give the 7 minutes to the participant. One person, one book. And the chambers. Welcome to the participant. Saya kembali ke tempat. Our next ceremony is to hand over the certificate and card to the next speakers. We will invite Professor Diansha. Professor Diansha, please join us on the stage to hand over the certificate and the card. Professor Diansha, dengan menggunakan sertifikat dan card. Suami Ismail, silakan. Okay, can you give applause for our speakers? Silakan. The certificate, the documents. Selanjutnya penyerahan sertifikat. Selanjutnya
penyerahan sertifikat mendapatkan yang pertama Suyadi. And our second moderator, Budi Sunario. The next we will have a picture together with the speakers and the moderator. Okay. To say thank you to the participant on Zoom meeting. Say thank you to the speakers on Zoom meeting too. Thank you so much. And then memberikan waktunya. I want to say thank you for the speakers and the fans Galish, and then it's
Bapak Ibu yang berbahagia, kita sedang memasuki kepada
dan beserta dan nanti sains itu kita 1 sampai 5 itu ada untuk bisa ngecek selain setelah bukan siang nanti mereka bisa langsung ke setelah makan siang bisa mengecek memberikan registrasi untuk dan siapa dicek untuk itu 1 sampai 4 itu berarti
jadi yang terima kasih sebagai